In a world where over 2 billion people still struggle with access to clean drinking water,
over 2 billion people globally are living without access to safe water.
the UAE has stepped forward with a revolutionary breakthrough. A drone-based system that generates rainfall using nothing more than controlled bursts of electricity. This isn't speculative science, it's a working technology developed through years of research and tested in the dry skies over Abu Dhabi. Unlike conventional cloud seeding, which disperses chemicals like silver iodide or salt into atmosphere, this new method leverages the natural physics of cloud behavior by using electricity to stimulate rainfall cleanly, precisely, and without leaving any environmental residue. The story of this innovation begins with the collaboration between the UAE National Centre of Meteorology and Research at the University of Reading in the UK. Their research showed that charging tiny cloud droplets with static electricity could cause them to clump together and grow large enough to fall as rain. Supported by UAE's ambitious rain enhancement research program, the theory was rapidly developed into practice. Specialized drones, many designed in partnership with firms like Stratton Park Engineering and UAE-based aerospace startups, were equipped with ionizing probes capable of releasing controlled bursts of negatively charged electricity into the air. Here is how it works. The drones are launched into the atmosphere and fly directly into cloud layers that have sufficient humidity. These are not ordinary UAVs, they are long-range autonomous aircraft built specifically for cloud electrification. Once inside the cloud, they emit brief high-voltage pulses through ionizing rods. These electrical bursts charge the tiny suspended water droplets, causing them to become more attractive to one another. Just like static electricity can make your hair stand up or attract dust to a screen, the charges in the cloud cause microscopic droplets to merge, a process known as coalescence. As the droplets grows larger and heavier, gravity eventually pulls them down to earth, resulting in actual rainfall often within 10 to 15 minutes of the drone's pass. What makes this system particularly powerful is its precision. Traditional cloud seeding requires manned aircraft, large quantities of chemicals, and blanket spraying of vast sky regions, often with uncertain results. Electric drones, however, can pinpoint individual isolated cloud cells that would otherwise be too small or uneconomical to target. They can be launched from remote areas, guided in real time by AI-based wind models and meteorological radar, and adjusted mid-flight based on evolving weather data. Their mission costs roughly $200 to $300 per flight, in contrast to over $1,000 or more for traditional chemical seeding flights, not including chemical cost or environmental remediation. Perhaps most significantly, these drones are reusable, clean, and scalable. Since they release no chemicals, there is no residue, no groundwater contamination, and no risk of long-term ecological disruption, a major concern in traditional weather modification efforts. In places like UAE, where over 90% of fresh water is generated through energy-intensive desalination plants, the ability to trigger natural rain using clean atmospheric techniques could dramatically reduce energy use and environmental strain. Field trials have already shown rainfall increase of 15 to 30% in targeted zones, with some dry regions receiving measurable rain for the first time in months. So who is behind in this breakthrough? The UAE's NCM has led implementation, while academic insight came from the University of Reading, Khalifa University, and Masdar Institute contributed advanced AI flight optimization. And companies like Spec and Volant Aerotech provided drone engineering support. It's a truly global collaboration, a blend of atmospheric science, aerospace technology, AI, and environmental policy, all converging to reshape how we think about water shortage. Now here is another question. Are these drones built just for this? Mostly yes, while some began as modified surveillance UAVs, but the latest models are purpose-built for cloud seeding via electric discharge. They feature customized ionizing hardware, reinforced airframes for humid conditions, and real-time cloud data integration system. Their ability to work in storms, adapt mid-air, and operate without pilot intervention marks as a major leap in weather modification technology. When we compare this to chemical methods, the difference is obvious. Chemical seeding involves the introduction of foreign materials into the environment, often with uncertain long-term consequences. It's expensive, slow, and not always effective. In contrast, electric cloud seeding is fast, clean, safe, and cost efficient. It mimics natural process rather than introducing artificial ones. And it doesn't just represent a new way to make it rain. It represents a new philosophy in environmental innovation, one that's smarter, greener, and deeply respectful of Earth's natural systems. In the end, this isn't just about rainfall. It's about rethinking how we approach drought, water shortage, and climate resilience in the 21st century. The UAE's electric rain-making drones show us that with the right blend of science, technology, and vision, we don't need to conquer nature, we can collaborate with it.